Hello and Assalamualaikum everyone. My name is Humaira Fasha binti Ahmad Tahrim. In this video's presentation, I will be talking about relations, function, and graph and how they are applied in computer science. First, let's start with the basic. What is a relation? A relation from set A to set B is simply a set of ordered pair, where A is an element of set A and B is an element of set B. In simpler terms, a relation connects element from one set to element in another set based on some rule or pattern. Every pair that satisfies this rule is considered related. But why does this matter in computer science? Almost every data structures and system, from database to algorithm to network, it relies on the idea of relationship between data. Relations are the mathematical foundation behind all of this. Now that we understand what a relation is, let's look at how a function is a special case of a relation. A function is a type of relation, but with one extra rule. Each input must have exactly one output only. This means every function is a relation, but not every relation is a function. Now, let's look at diagram 1. We have the relation R0, 1, 0, 2, and 3, 4. Notice that input 0 has two arrows. It maps to both output 1 and output 2. So this breaks the function rule. So this relation is not a function, but it is still a valid relation, but not a function. Look at diagram 2. We have R1, 2, 2, 3, and 3, 4. Here, each input 1, 2, and 3 has exactly one arrow each, pointing to exactly one output. This satisfies the function rule, so this relation is a function. The key takeaway here is a function is a stricter version of a relation, since every function must first be a relation, so a function is considered a special case of a relation. Now, let's prove this through calculation using the same relation from our previous slide, which is R is equal to 0, 1, 0, 2, and 3, 4. First, step 1, we need to find the domain. The domain is the set of all first elements or inputs in each ordered pair. Looking at our relation, the first elements are 0, 0, and 3. Since 0 repeats, we will only write it once. So our domain is 0, 3. Step 2 is we find the range. The range is the set of all second elements or outputs in each ordered pair. The second elements are 1, 2, and 4. So no repeats here, so our range is 1, 2, 4. Next, step 3. We classify the relation by checking the function rule. So we go through each pair one by one. First, 0, 1. Input 0 goes to output 1. So this is the first time we see input 0, so this is fine. 0, 2, input 0 goes to output 2. But wait, input 0 already appeared in the previous pair. Now input 0 has two different output, which breaks the function rule. 3, 4, input 3 goes to output 4. Input 3 only appears once, so this is fine. Since input 0 appeared twice with different outputs, R is not a function. However, it is still a valid relation because it is still a set of ordered pairs. Here, let's look at the same relation from a different angle, which are through a graph. A graph is simply a relation plotted visually on a Cartesian plane. Every ordered pair becomes a point on the graph, where A is on the x-axis and B is on the y-axis. Using the same relation R, 0, 1, 0, 2, and 3, 4, we can plot each ordered pair as a point. First, 0, 1 is plotted at x equals 0, y equals 1. 0, 2 is plotted at x equals 0 and y equals 2. And 3, 4 is plotted at x equals 3 and y equals 4. Now, we apply the vertical line test. The vertical line test is a quick visual method to check whether a relation is also a function. If a vertical line drawn anywhere on the graph touches more than one point, the relation is not a function. As you can see in the graph, when we draw a vertical line, at the x equals 0, it touches 2 points, which is 0, 1, and 0, 2. This means R fails the vertical line test. Therefore, R is not a function, which gives us the exact same conclusion as our calculation in the previous slide. Now, let's look at how relations are applied in real computer science system. First is relational database. A relational database table is simply a set of tuples directly applying the mathematical concept of relation. Each row in the table represents an ordered pair connecting a primary key to its attributes. For example, student ID 101 maps to the name Ali and student ID 102 maps to the name Siti. Since each student ID has exactly one name, so this is actually a function, which are a special case of relation. Second is graph and network. A network or graph is a relation between vertices where connection can be symmetric for undirected graph or one-directional for directed graph. For example, social media platforms like Facebook and Instagram use this concept to model friends or follow relationship between users. Since one user can follow many others, this is a relation but not necessarily a function. Third is state machines. In automata theory, the transition function is a relation connecting states and input to the next state. Every time an app changes from one screen to another based on your input, a state machine relation is being applied. This three example shows that relations are not just an abstract mathematical concept, but they are the foundation of how data is stored, connected, and processed in real computer science. To conclude, in this video presentation, we have covered three main concepts. First, a relation is a set of ordered pairs connecting elements from set A to set B, which is the most general way to link data between two sets. Second, a function is a special case of relation, where each input has exactly one output. We proved this both through mapping diagrams, step-by-step calculation, and the vertical line test on a graph. Third, a graph is simply the visual representation of a relation where each ordered pair is plotted as a point on the Cartesian plane. And finally, we saw how these concepts are applied in real computer science systems, which are in relational database, graph and networks, and state machines. So the conclusion of this presentation is every function is a relation, but not every relation is a function. Thank you for watching. Bye-bye.